All right, find the equation of the tangent line to the graph. So if we're trying to find the equation of a tangent line, you always know we need two things. We need the point and we need the slope. So, oh, hang on. They didn't tell us where to find the slope of the tangent line. So we can just make it up ourselves. Let's find the equation of the tangent line at x equals 2. Maybe that'll be really bad, but let's do it anyway. So we need to find the slope and we need to find the point. So let's find the point first. So we know the x value of the point because it's when x equals 2. What is the y value of the point? Well, we're going to find the y value of the point by just finding f of 2. So we'll do 3 minus 1 half over 2 plus 5, which is 7. Not 2 plus 7, 2 plus 5. So then what do we get there? Well, 3 minus 1 half is 5 halves. So we have 5 halves over 7. So we multiply by 1/7. So 5/14. Oh yeah, this is going to be fun. So the point that we're looking at is at 5/14. So now we need to find the slope of the tangent line. So what's the slope of the tangent line? That's the derivative, always. So let's find the derivative. And now we can just use the quotient rule because now we know the quotient rule. So it's just that divided by that. So let's do that. So what's the quotient rule? Let's write it out. So we're going to do, if we're trying to take the derivative of f of x divided by g of x, we're going to do the derivative of the top first times g of x minus derivative of the bottom times f of x all over g of x squared. So let's do it. So the derivative of the top, well, the derivative of the 3 is 0. So what's the derivative of 1 over x? Well, it's just kind of nice to remember the derivative of 1 over x is negative 1 over x squared. So we already have the negative there. So that should just be 1 over x squared times the bottom, times g of x. So times x plus 5. And then minus the derivative of the bottom, which is very conveniently just 1, times the top function. So times 3 minus 1 over x. And then all of that is going to be over the bottom function squared. So that's the derivative here. So now what we got to do is we got to find the derivative where we want it. We're at x equals 2. So let's do that. So let's find f prime of 2. And if you're going to plug in a number, it's often fine to not simplify before you plug it in. It's often easier to just go ahead and plug it in, and then you'll simplify how you need to there. So this is going to be 1/4 times 7. So that's just going to be 7/4. And then minus 3 minus 1 half. So that's 5 halves again. And then all of that's going to be over 7 squared. So 49. So what's 7/4 minus 5 halves? Well, 5 halves is 10/4. So 7/4 minus 10/4 is negative 3/4 over 49. So times 1 over 49. 4 times 49 is 196. So we end up with negative 3 over 14 squared. That's another way to see that it's 196. Or I should just say 196. Okay, so that was probably not the easiest point to choose, but now we can write our equation. Because remember, the easiest way, the nice, simple, easy way to write the equation of a line is just point-slope form. Slope times x minus x1 equals y minus y1. So from now, we're just going to use that. So, well, it's not 196 squared. It's 196. So we're going to have our slope, negative 3 over 196 times x minus 2 equals y minus the y value we calculated, which is 5 over 14. Okay, and you know what? That's not bad at all. Because now if we multiply both sides by 196, you just get negative 3 go ahead and distribute. Negative 3x plus 6 equals 196 y minus 70. So that's not that bad, actually. We put that in standard form. Yeah. So it becomes 3x plus 196y equals 76. That's kind of beautiful. Let's go to Desmos and make sure that's right, though. If it's not, I'm going to be very upset and have to redo the entire thing over. So what was the equation? So the equation is 3 minus 1 over x, but then all of that divided by x plus 5. So there's the graph that we were doing. So it kind of looks like it makes sense. So first, let's make sure our point's on the graph. Let's look at the point 2, comma 5 divided by 14. Yeah, there it is right there. And so you can see how that tangent line is super flat, which makes sense because that's what we found. So let's type in our line. 3x plus 196y equals 76. Boom. There you go. Perfectly tangent at that exact point. And that's the beauty of calculus. That's one of my favorite things to do with calc. To check your answers, you get to graph the tangent line, and you get to make sure that they're actually tangent. And everything we did looks so complicated, but you see, in the end, it was all correct, and it was the tangent line.